okay, very flexible. And the bell is a good exhaust. Yeah, so there is a vibration. The bell is able to exhaust, but it's difficult for the gear. Yeah, if there is a shock or vibration, that is can be make your alignment is missed. If you use a gear, yeah, that's why the gearbox, yeah, that is very sensitive compared, let's say, in the bell. Bell is very simple. As long as you tie in, then you can use. Yeah. Another one is uh, it can take care of some degree of misalignment between the driver and the driver machine, yeah, and long distance power transmission compared to gear system. Yeah, this is the most important. Yeah, this is the most important. Is take care of some degree of misalignment. Yeah, that is can't accept another type of uh, power transmission misalignment. Let's say if your motor with driver to driver is not aligned with some degree, then the bell is able to accept the misalignment compared with the again the gear is need to perfect. Yeah, the alignment need to perfect. Otherwise, it can be anything. Maybe the gear is broken. Another one is noisy. Yeah, but for the bell, it's not. Yeah, can run smoothly with the misalignment. Yeah, with some degree. Yeah, it's not at all. So let's say uh, one to one like this is not aligned, then it's okay. Let's say 5 degree, that is still accepted. Yeah, compared with the gear, that is you can't. Another one is the usually mode of cartons, usually made from the cotton, rayon or nylon, yeah, impregnated with the rubber. Okay, if you are looking in the uh, uh, bell, yeah, mostly made by, there is a rubber outside, but inside there is a lot, can be anything. There is a wire also, there is a cotton, there is a rayon, there is a nylon. Maybe that is combination all. Yeah, depend on the function. If the power transmission is high, then the inside of the rubber is maybe steel, wired. Yeah, that is increase the properties of the bell. Yeah, you can analyze based on the function later. That is another type. A single fee bell is less efficient than flat bell, yeah, due to the wedging action between the bell and the pulley, high pressure. Yeah, but the multiple V bell can be used to transmit high power. Yeah, this is the comparison. Yeah? Single V bell is less efficient compared with the flat bell. Yeah, in term of wedging action between the bell and the pulley because the high friction. Okay. However, yeah, by using the V bell, multiple V bell can use transmit high power. Yeah, that is flat bell is can mostly the high power we can use the gear or other power transmission. Yeah. But with the multiple V bell, we able to transmit with the high power. That is the most advantage of the V bell. Yeah. Bevel are longer in life due to seamless design, no joint, yeah, compared with the flat bell. If you are noted in a car, that is very rare. We change the bell. Maybe a year, maybe not. Maybe 2-3 years. Then you can change our bell. Yeah, the price also really cheap compared with the other power transmission. Yeah. Bevel are used for the short center distance. Yeah. Compact, an example compactness, compared with the flat belt. So V-well are used the short center distance. Yeah, short center distance. One center to another center is very short compared to flat. Flat can be more longer compared with the short one. Okay. V-well are manufactured in the standard line. Okay. Yeah, bevel are manufactured in the standard line. Okay, that is different with the other method. Yeah. The method which is uh, actually bevel flat bell manufactured is not really standard. Yeah. Yeah. You can request, but in the V bell manufactured in the standard line. Then you just design the length, then you can find the similar size and the similar size available in the market. The group angle of the shape is made somewhat smaller than the bell section angle. Yeah, this causes the bell of the weight is itself into the group. Thus increase the friction. Yeah. The group of angle its shape is made some smaller than bell section angle. Yeah, that is uh, the general about the V bell. Yeah. Here the overview. Here the overview of bell. Yeah. If you are looking here, here is the V bell. Yeah. This is the transmit the power. Okay. This is the rotation in this angle. Okay. That is the one example of the V-bell. Okay, this is the V-bell construction. Yeah, right V-bell. Yeah, if you are cover fabric in the first, number one. Yeah. Don't know why I can't write. And the two is adhesive rubber, and three is the cord. The cord actually to strengthening of the structure. Yeah. And the four is the compression rubber. Okay. Yeah. There is four component in the V bell. Yeah. There is in the right V bell. The first is copper fabrics. Second is adhesive rubber. And the third is the cord. Fourth is compression rubber. If you the cord function is the most important. Yeah. One is the most important, the cord. It is improve or strengthening your structure. Yeah. Classical V-bell for RMA or MPTA, classical V-bell are most wide use power transmission belt. Economical and easy obtain for replacement. Yeah. That is the main factor why the V-valve is mostly used in our device. There is a section, write type A, B, C, D, E, row H type, yeah, AX, BX, CX, yeah. That is you can check in the catalog. I will share the complete catalog later. Yeah, working temperature. Yeah, ripe time is minus 40 plus minus 158 degree Fahrenheit. Row A type is minus 22, yeah, plus minus 194 degree Fahrenheit. Electrical connectivity, sustainable for RMA IP3-3. Okay, this is the cross-section size of the V-band. Yeah. In the A, okay, if you're in the A, the height is 0.31 inch. Yeah. Okay, the height. The width is the 0.5 inch. Okay. And the B, 0.41 inch. The width is 0.66 inch. Yeah. But inside there is a core. Yeah. There is a compression rubber that is complete. Yeah. This is the standard cross-section V-bell. Yeah. All bell have the rubber impregnated fabric jacket with the interior tension cord above a rubber cushion. Yeah, you can check here the size, the standard size of the rubber, A, B, C, D. Yeah, that is depend on you. That is depend on the pulley available in the market. Then you can select of the V-band. Yeah, this is you can refer the Mitsubishi catalog. Yeah, table 1, 2, 1 and 2 to table 1 till 6. Yeah, for bell code, outer length LA and datum length LD. Yeah, you can refer with this one. Okay, set condition required in design work. Yeah, and then if you want to design of the bell, if you want to design the V bell, the set condition required in the design work. The first is type of the machine. Yeah. You looking deeply at the type of the machine and the transmission power. How much the transmission power? Running hours in the single day. Yeah. They say in a day you just use 1 hour or 24 hours, 8 hours, 18 hours. Depend on the machine. Depend on the activities of your design. Small pulley speed, yeah, interim center distance, spatial use and the environmental condition, and the G is the speed ratio. Yeah, that you need to look deeply. Yeah, in terms of the machine, power transmission, how much the power you want to transmit. Running hour, this is one the most important. Yeah, small pulley speed, high speed, or slow. Yeah, then you need to determine what is the function of that one. Ratio speed from this one, you can calculate by motor speed, RPM, and the RPM on the machine. Yeah. D pulley diameter, and DD is safe diameter, and the motor speed and the end machine is the machine speed. Yeah, you can refer on that one. They need to more than one. This is the compound belt drive. This is multifunction. Okay, there is a three. Okay, you can calculate based on that one. I think that is similar. Yeah, speed ratio. Then it depend. Yeah, drive and driving. Then how much the ratio? Then what is your target? They say the motor speed 2000. Then you want to reduce. What you can use? Yeah. Then the driver is smaller than driver. That it depend. Yeah. If you want to high speed, yeah. If you want to high speed, the driver is high diameter, yeah, and the driver is lower. Then you can increase the speed. Depend on you. Yeah. You can calculate, use this equation. Yeah. Two is set the design. Yeah. Power. Yeah. That is the factor you need to consider. Yeah. This is all the factor you need to consider. The KO, yeah, service correction factor. KI is idler correction factor. KE is environment correction factor. KS is service factor. KS is equal to KO plus KI and the KE. Yeah. HT, the transmission power. The DHD is the design power. Yeah. Then you need to consider all this one. You can check to the next slide. Yeah, how you can define the KO till KE. Yeah, what is the function on all these things? This is example the surface correction factor. Yeah, if you are looking here in the table 2.1, yeah, there is a driven machine. Yeah, in the left side, okay, you can check here what is the driven machine and the driving unit or motor. Yeah, maximum power less than 300% of the rate power. Maximum power is more than 300% of the rate power. Yeah, you can check also here the AC motor single and three phase with the star delta star. Yeah, DC Sang Won motor multiple cylinder internal combustion engine. Yeah, you can check on the detail, and you can check the running times hour per day. Okay, that is how many hours. They say operational is 3 till 5 hour per day, 8 to 12 hour per day, or 16 to 12, 24 hour per day. Yeah, that is the correction factor. Yeah, the lower is 1 the correction factor till 1.8 correction factor. Yeah, that is depend on the operational. Yeah, that is depend on the operational. Yeah, you need to uh, uh, memorize this. Yeah, uh, in this table you need to understand. Yeah, you need to check detail on the left side. Yeah, driven machine, and the driving unit motor, or the motor. Okay, that is simple actually. Yeah, you read carefully, then you understand. Okay, this is idler correction factor, KI, table 2, 2. Yeah, if you're looking here, yeah, there is a driver driving. Yeah, there is a idler. Then you need to detail the location of the idler. Yeah, if you are, there is the small of gear, the small of the pulley. Yeah, that actually to strengthening, or to maintain from the to neglect the slip of the power transmission. Yeah, you can put, let's say, in the underneath, yeah, 2 pulley, yeah, or in the top 2 pulley, or one in the top, one in the bottom. It is depend on you. Yeah. Okay, if you check here location of the idler, yeah, belt slide inside of the belt. Okay, belt slide outside of the belt. Okay, belt tight side inside of the belt, belt tight side outside of the belt. That is the KI. Yeah, start from 0 till 0.2. That is the idler correction factor. Yeah, you can check, yeah, the arrangement, which one is fit to you. Okay, this is the overview. This is the overview of the correction idler. Yeah, the increase of the arcs of the contact top recommended. Yeah, then you can put the one pulley on the top. Yeah, that is recommended. Then if you put it underneath, yeah, that is not uh, uh, recommended. Yeah, and another one, decrease arc of the contact. Yeah, yeah, decrease arc of the contact. Then you put the pulley inside, yeah, inside the slide. Okay, that is the recommended. Okay, the driver, yeah, not recommended is you put under underneath, yeah, of the pulley. That is not recommended. You need to understand when the better you put it, you add another pulley. Yeah, that depend on you. Yeah, increase arc of the contact, or you want to decrease of the contact. Yeah, depend on the function where you add another pulley. Okay, another one is the environment correction factor. Yeah, environment condition, frequent start and stop on the machine. Okay, this is like auto, the auto, let's say, and the compressor. Okay, in the factory, they will frequent start and stop. Okay, use the air pressure, then reduce the pressure for the certain amount, then the motor will be on. That is on off. Yeah, the frequent start and stop of the machine. Then the correction factor is 0.2. That the hard to conduct maintenance check-up, yeah, that is 0.2 also. Dusty environments, also 0.2. High temperature is 0.2. Oil or water splicing, that is also 0.2. To avoid oil and the water splash, cover to prevent the belt slipping. Yeah, you need to give the cover. Yeah, to avoid the oil or water splashing on the cover. By cover, we went in the bed. Yeah? That is really important. Here, actually, you select type of the bell. Select the bell type. A, B, C, D, E. Okay, you have the size in the beginning. That is the size A, B, C, D, E. Then here you can determine which one you want to use. Smaller pulley speed, yeah, that is depend on the speed, okay, and the design power. If the power uh, higher, the power is higher, more than 50 horsepower, then you can use the E. If your uh, uh, power is 20 to 50, then you can use the D. Okay, or you can use the 5 horsepower till 20 horsepower, you can use the C. And is if the horsepower is, let's say, 1.5, you're able to 10,000 rpm. Yeah, that is depend on you, depend on the application. Yeah, then how you design, you can choose what type of the pulley. Yeah. Any question? Then you can choose here, the select the pulley size. Here, this is how to select the pulley size. Okay, minimum pulley datum, yeah, diameter, the bell type, minimum pulley datum diameter in inch. Yeah, you can choose 3 inch till 17.7 inch. Yeah, uh, that is A, B, C, D, E. And belt type is AX, BX, CX. Yeah, you can choose that one. The width difference between the pulley outside diameter and the datum diameter is specific to follow table. Yeah, you can follow the table 2.2, table 2.5. Yeah, the unit is in the millimeters. Yeah, and in the top is the unit is inch. Okay. Okay, the bell type is different. Okay, M, A, B, C, D, E. Yeah. Okay, for this table, section A, B, C, D, E, that is still the same. Top bell, datum width, height bell. Yeah, you can check here. Recommended is pulley datum diameter is the 3, 5. Yeah, you can check here. And recommended maximum bell speed is 5,900 rpm. Recommended minimum pulley diameter is rho 8 Compt Design. Okay. This one is the how you determine the bell length. Okay. You need to remember in the beginning I mentioned about the V bell manufactured with the standard size length. Yeah. With this one, okay, you can determine the belt length, then you can find the similar size in the market. The first condition, if the center distance is not confirmed, use the following formula to determine interim bell datum length. Yeah? The first option, yeah, the center distance is not confirmed. Yeah, that means you can adjust somehow. That is use this equation. The second is if the center distance is confirmed, use this equation. Yeah, LD action is 2C plus blah 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 blah. You can follow this equation. Okay. Or you can calculate the center distance. You can calculate the center distance. How? The C can be calculated with this. The C, yeah, you can follow that equation. Where the B, that one. Yeah. You need to remember during the determine the belt length, the center distance confirmed or not. Then you can choose the equation. Yeah. That is two different. Yeah. You need to be careful. And the distance. Yeah. Another one is determine required numbers of the bell. Determine required numbers of the bell. That what? Yeah, you can check here the correction power rate of bell, head as the basic power rate per bell. Yeah, you can follow this one. Yeah, you can use this. How much the numbers of the bell? Yeah, NB. Okay. HD. Yeah. Transmission design power. AC corrected power rating for the bell. Then you can determine numbers of the V bell. How much you want to use the multiple. Okay. Section power rating here. Yeah? You can check here how much the speed, how much the small pulley speed, how much the speed. You can check here. Then the basic power rating for the small pulley datum diameter HS. Another one is small pulley datum diameter in inch. Yeah. And another one in the right side is additional power rating for speed ratio SA. Okay, that is the speed ratio. You can determine the section power rating. Yeah, you can select how much. And bell length correction factor for the classical bell V bell KL. Yeah, here the bell length correction factor. Length destination. Yeah, that one. That is type of the V bell. Yeah, A B C D E. Then that one. You can have the correction factor, bell length. That is how much the correction factor. Okay, you can check here. Arts of contact correction factor. Yeah, you can determine here also. Yeah, you need to check. You need to check the arts of contact correction factor. K theta. Okay, that is how the contact. You can check from this table. Here the formula for V-bell driven design. Yeah, the angle of drive for the small pulley. Yeah, you can use that one. That is, you can determine the angle, and the angle of drive for the large pulley. Yeah, that is depend on you. Yeah, you want to use the small pulley or a large pulley. Yeah, then you can determine. You can choose the equation. Here the tension. Yeah, tension due of the centrifugal force. Yeah. Okay. You can use this one. Yeah. Centrifugal force, the PC. Okay. G is gravity, and W is the mass per unit length of the bell. Yeah. That is bell weight per unit. Yeah. W and the constant, that is Y. Okay. You can check here also. 1/5 is, this is the, inilah ya, kalau you nak tengok macam mana you nak transmit. Okay, you can check here. Then you need to detail about the every table. Okay, oh, there is a factor this table. There is a factor this use this table. Okay. And the formula for bevel driven design, yeah, still the same. The tension on the tight side. Okay, that is the equation. Straightforward, yeah. The tension of the slack side, Ts. Then you can use this one. That equation. I think that is you need to remember for this equation is the one bell only. Yeah, you can use this for the one bell only. Here is the pulley dimension and measurement force of classical V-bell for RMA or MPTA. Yeah, that is the size, type. Yeah, then you can know the pulley dimension and the measuring force. Yeah, that is how the force involved. Okay. Tension ratio. Yeah, TT divided by TS, and the effective tension. Yeah. 2 multiplied by torque transmission, yeah, divided by DD, okay, or TT minus TS. Okay, that is effective tension. Yeah. Then you can refer the formula at the Mitsubishi catalog. Yeah, I will send in the e-learning by today. Yeah. Any question? I think for the bell is straightforward. Yeah. Nothing much tricky. Yeah, that is straightforward of straightforward. It's not the tricky lah. I think it should be king. Any question? Okay, if not, before Raya, we have small presentation, right? Every group, but it's not finished. Okay, I will continue for that one. If there is no question here, I will continue for that one. Any group yang belum? Siapa group yang belum? The note is actually in my office. but I can't enter office now, so I don't know who has present or not. I can check in the video, but if you are, I think uh, you can mention to me. I'm finished or not. You need to present. Eh? Okay, grup mana yang nak present dulu? Yang belum eh? Tak ada ke? Oh, tak nak present. Kalau tak nak present, then the mark is tak ada lah. Okay, Haris, group 9. Okay, boleh Haris, your group kan? Okay, who want to present? You can share. You can share. Hello. Haris, siapa yang present ni? Okay, Haris, you can start. Afif ke? Afif, I think Haris ni dia tak ada mic. Afif mana tadi ada? Haris, Afif mana? Okay, if there is a problem, still a problem, and maybe group lain yang belum? Afif, you can present, Afif.
Hello, Doctor.
Sebelum buat apa maksudnya ni, Haris? Oh, Google Meet. Susah, Haris. Nanti semua orang nantilah by Wednesday. Okay. Wednesday we use the Google Meet. Okay, Haris? Present on the Wednesday, eh? Okay. What are the group? Tak ada lagi ke? Just group 9 yang belum, yang lain sudah semua. Okay, Azizi.
Hello, Doctor. Hello. Hello. Hello, Doctor.
Azizi dengan Zulaika ni the same group ke?
Lain. Doktor dengar ke, Doktor? Boleh nampak ke slide?
Start, okay, nampak.
Nampak?
Okay.
Okay. Ini lain.
You can press the present tu. Jadi dia full view lah.
Okay, Assalamualaikum dan selamat pagi. Hari ini saya akan present tentang major projek grup saya. Grup saya ada saya, Abdul Rahim, Ilian Najah dan Muhammad Azman. So, problem statement grup kami adalah untuk choose better selection of motor, gear and belt that can optimize the refrigeration system. So, kami pilih refrigeration system as our compressor yang dipilih. So, our objective for this project is to design an optimal mechanism to drive a reciprocating compressor in refrigeration system by calculating the certain compressor performance. So this is our product design specification, which is we choose maximum pressure 15 bars, capacity multiplied by 2 meters squared per hour, and we choose double air cylinder for our compressor.
Okay, good.
So basically, this is our design of reciprocating compressor, which is we choose an example from the internet. where there is some of the components in the compressor. So for extra information, the compressor is to circulate the refrigerant in the system under pressure. This concentrates the heat it contains. At the compressor, the low pressure gas is changed to higher pressure gas. So these are some components that we try to analyze in the compressor, which is the cylinder, the piston, the valve, and the connecting rod. This is our selection of motor, which is a three-phase induction motor. We choose this motor is because it is an electric motor that are reliable, economical, and capable of generating enough power for standard use. So I think that's all from our group. Thank you.
Uh, I have one question. Why you choose three phase? Is it?
Because it is capable to generate power for the compressor.
Okay, means okay, three phase able to generate more power compared with single phase.
Mm.
But you need to consider where this aircon refrigeration system were used. Let's say in the house, that is mostly in the single phase. Okay, you can use the three phase, but you need to careful. Okay, this application where in industry or in the house,
In the house.
in the house.
Yes.
Okay, so um, for me, you can choose later for the motor, but that is depend on the power that you need.
Um,
Okay, then after that you select the motor. Okay, you design the compressor first. I think you able to calculate the power that used for uh, 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 you can calculate the power of the compressor. Then from the power of the compressor, then you can choose the motor.
oh, okay.
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 Don't choose the motor first without you finish the calculate the power of the compressor. Yeah, that is for all. It's not for this group only.
Hmm.
Okay, I think good. Uh, Mana yang lain, Azizi?
Itulah diorang buka. Hello guys, buka suara.
Hello.
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 Semua adalah.
Ada.
Uh, 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 I hope the next presenter is changed. So everybody have the feeling to present something. Okay.
Okay.
Thank you, Azizi.
Okay.
Ada grup lain ke yang belum?
Grup saya,
Siapa tu?
Fahmi.
Okay, Fahmi. You group number?
Number 2, sir.
Okay.
Nampak ke, sir?
Nampak?
Hello, Assalamualaikum everyone. Today I will present about our group project. We choose reciprocating compressor. My group mates is Nur Akila Natasha, Julaika and Nur Jihan. So our problem statement is to design a reciprocating compressor with maximum pressure of 10 to 10 bar and capacity 12 meter cube per hour to be used in refrigeration system. So this is model of our compressor that we choose, that it is available on internet, which is as our guideline, which is LF series, Atlas Copco oil free reciprocating compressor. This is used in car painting industries. Product design specification is capacity is 12 meter cube per hour with maximum pressure of 10 bar. It uses single stage 2 cylinder and electric motor with 1.5 kilowatt. The basic components of reciprocating compressor is crankshaft, piston, cylinder, connection rod, suction valve, and discharge valve. And that's all.
You use automotive system.
In car painting,
No, I mean the refrigeration system used in where you can use this application.
in car painting shop.
Oh, this one is not for refrigeration. That is for the car painting.
Yeah.
Okay. Boleh tak saya pergi in the front PDS? Okay, this one.
Which one?
No, next one.
Specification.
Yeah.
Okay.
Okay, like this. I'm okay with the two in the top. Yeah, capacity, maximum pressure. Okay, and the single two-stage cylinder, motor 1.5 kilowatts. Fahmi?
Yeah.
Saya nak apa nama itu, with the capacity, with the maximum power, maximum pressure, you can determine, you can determine the power, the compressor is single or two states. Okay, that is based on the calculation. It's not okay. If like this, ini untuk semua untuk all the group. It's not only for this group. Saya I don't want to you just select off the compressor. I don't want to you select off the compressor. So I want to buy this compressor. No, I want you select type of the compressor. Let's say the reciprocating with the capacity 12 meter cube per hour. Okay, with the maximum pressure 10 bar. From that one, you can design all these things. Yeah, you can choose how many piston you can use. Maybe you can use 1 piston, 2 piston, 3 piston, 4 piston, and above. Depend on you. Okay, then you can calculate the power of the it's not the compressor. How much the energy you need to rotate to generate a capacity 12 meter cube per hour with the maximum pressure 10 bar. Let's say you got 1.5 kilowatt, right? Then you can select the motor. Here, like you buy the compressor. No, I want to design the compressor with the main component that you show me before. Kan, cuba you pergi next slide, ada kan komponen-komponen dia?
This one.
Okay, that is crankshaft, piston, cylinder, connecting rod, section bar, distance bar. Yang inilah you akan design. Ya kan? Piston, what size of the piston? Before you determine the size of the piston, that you need to determine the cylinder size. Understand to all? Yeah, I don't want you like beli, there is a guidance, that is okay. Okay, you want to choose, let's say, reciprocating with this, that is just guidance. Okay, I want you calculate, you just have to make, yeah, spec, the flow rate and the pressure. Rest you can calculate.
Faham?
Faham, eh? Okay, good.
Okay.
Any question from the group, Fahmi?
I think that's all. If ada soalan nanti saya tanya.
Okay,
Okay, thank you. Terima kasih, sir.
yeah. Any group yang belum?
Sir, saya nak tanya.
Okay, siapa ni?
Fizi.
Okay, Hafizi.
Saya nak tanya yang untuk pressure tu kan memang dalam projek tu dah stated maksimum 15, tak salah saya kan. So,
Okay.
kita pilih antara value 0 sampai 15 lah kan. Lepas tu
Ah.
yang capacity tu, dekat ayat dia depending of number of group and multiply by 2, tak silap. So, maksud dia kita kena ambil nombor genap ke macam mana?
Tak, you boleh ikut tu, or depend. Why I make it like that? Because if all of you make the same, so dia tak ada beza nanti. Faham tak, Hafizi? So kalau saya tengok the application now, currently the application is widely, yeah, very wide lah. Ada untuk painting, ada untuk aircon, that is a refrigerator, aircon system. That is different application. Betul Hafizi? Then no need for you to follow that one. I don't want to suddenly semua group select reciprocating application for refrigerator with the same capacity, the same flow rate and the same pressure. Then you just copy and paste. I don't want to do that. That's why I make ini. Tapi for this, no need, because the application is widely lah. Ada yang painting, macam tadi kan ada yang refrigerator, yeah, and there is aircon system. Okay, Fizi, it's not you can asking me, yeah, regarding that one. You can follow that one also. There should be no problem. Okay.
Maknanya kita boleh freely ambil nilai yang kita nak untuk projek lah macam tu.
Yeah, depend on the application. Let's say Hafizi, what application?
Home aircon.
Aircon. Okay, right. What type of compressor?
Reciprocating.
Reciprocating. Then the aircon reciprocating. Then you calculate lah. How much the capacity? Let's say kalau that is okay lah. In the aircon system, you dah belajar kan refrigerator? Atau belum lagi Hafizi? Aircon design?
Refrigerator tak, aircon tak dalam
Dia sebenarnya ada load. There is a load in the I don't want to do that lah. Let's say normally in aircon system, yeah, in the house, big capacity, kan, there is a capacity, load capacity. Load capacity that is determine the power of the system, right? So you have the load and everything. You just determine what the flow rate of the compressor and how much the pressure in the compressor. Then the rest you can design.
Faham. Thank you.
Okay.
Hello.
Yeah.
Okay,
Haris.
ya.
Dah ada suara ni Haris. First time dengar suara Haris ni.
Saya guna phone je.
Okay, good.
Boleh nampak slide?
Boleh. You can ini full kan? Slide show kan, Haris? Okay.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, our group 9 represent our reciprocating system. Okay, our application is leaf blower for cleaning like at the road. Okay, our problem statement is that we aim to improve the efficiency of the leaf blower.
Okay.
Design the scripting operator to improve the performance and efficiency of the leaf blower.
Okay.
So our type of compressor, the reciprocal compressor, using 2 cylinder, which is single acting. So,
Haris, your slide is freeze. Tak gerak ke slide ni Haris?
bergerak tapi dalam saya punya PC gerak.
No, it's okay, tak apa. You continue.
Basically, we use like the current design of leaf blower use centrifugal compressor. So now we use reciprocating compressor. So
Okay.
our group will design a more stable like backpack wind leaf blower.
Okay.
So the component is cylinder, both have in and out valve, a motor at the upper side of the like backpack. Upper side is the motor, and there's a crankshaft connecting from motor to the cylinder. So the pressure, so we don't decide yet, but the capacity is fixed, right, sir?
Okay. You need to determine at least two apa namanya Haris ya. The first is cylinder, capacity and the pressure you need to determine. Okay, capacity, okay, you dah fix kan, that is you kena bagi tahulah how much the pressure, how much the capacity, the flow rate, and how much the pressure for this application. Okay, I don't want you you can make survey lah. You can make survey how much the pressure you need to what the application tadi, Haris?
Leaf blower.
Leaf blower. Yeah, mostly how much the pressure. You need to I don't want you design. They say the leaf blower tu, kan? Nanti you design then you nak dapatkan pressure dia. I don't want to do that. Okay, I want you make survey or from your reading, how much the pressure do you need?
Okay, sir.
Faham, Haris?
Faham.
Saya tak nak you design tau. Nanti dia banyak, nanti dah over pula. Saya nak you ada pressure dia. You dah determine the pressure tu. Ya kan? Dan tu you ada capacity tu. Cukup. Then from that you calculate everything.
Okay, sir.
Okay, I don't want you design design of the pressure tu. The blower tu. I don't want. Nanti banyak kerja dia. Saya nak you fokus kat sini saja because the component sendiri of the compressor you kena design and nanti ada power transmission lagi, ada bearing lagi, ada macam-macam lagi. Okay, Haris.
Okay, sir.
Okay, good. Thank you, Haris. Ada grup lain ke lagi yang belum? Okay. Tak ada saya nak panggil satu-satu. Haris ada tadi Abdul Rahim. Tadi ada juga. Afif. Mana Afif ni? Afif?
Ya.
Mengapa tak bantu Haris present tadi?
Sebab saya tak faham apa yang saya nak macam nak bahagikan, saya nak bahagian depan dan Haris ambil bahagian pre-design tu.
Okay, next presenter you. Okay.
Okay.
Okay, good. Irene?
Ya, Doktor.
Irene, you group berapa Irene?
4.
4 dah present kan?
Dah.
Okay, good. Hafizi group berapa Hafizi? You dah present juga ni.
Present, Doktor.
Ya, group berapa?
Sekejap, saya group saya group 9 tak salah, saya ingat tak.
Alah, baru je hari ni kan? Mana boleh tak ingat FPC. Okay, good. Akmal Darwisi.
Yes,
Are you okay, Akmal?
Okay, sir.
You dah present ke?
Dah.
Group number?
Number 6.
Okay, you ada di UTM ke?
Tak ada. Dekat rumah.
Kat rumah baiklah, jangan banyak jalan lah kat rumah je.
Baik, insyaAllah.
Okay. Akila. Akila dulu ni. Alia Akila.
Yes, sir.
Ya, panggil Akila tenang rupanya. Akila bawah. Okay.
Selamat Akila, sir.
Itulah. You group berapa Akila? Alia Akila.
Saya group 8.
8. Okay. Dah present You dekat mana sekarang? Dekat UTM ke?
Tak, sir. Saya dekat rumah.
Okay, good. Okay, thank you. Akila Fadlina. Akila Fadlina. Ayu? Azizi?
Ya, Doktor.
Okay. Azizi kat mana Azizi?
Kat rumah ke?
Kat
Kat
rumah
Kelang.
Salam. Okay lah. Dia kena be careful tau. Selangor tu. Azman. Azman. Dia dah turn on tapi tak ada voice.
Hello.
Sehat Azman?
Sihat.
Dia grup berapa?
Grup 7.
Grup 7. Okay. Sudah sampai mana progress you buat?
Oh, tadi baru present. Dengan
Okay.
Azizi.
Ada lebih dari yang tadi ke?
Belum.
Belum lagi.
Hmm.
Okay. Thank you Azman. Diana Ismail.
Saya doktor.
Ya. You dekat mana sekarang?
Rumah.
Kat rumah dekat?
Skudai.
Sudah dekat je saya fikir. Tidak sebelah rumah saya je Diana. Apa namanya? Your group berapa?
Saya grup kejap lah. Saya lupa nombor apa. Tapi sama dengan Suhaila. Oh, grup 3.
Aduh, Diana ni.
Grup 3.
Okay, everything okay
Okay.
Kena jangan banyak keluar lah. Rumah you dekat Paradigm, jangan selalu pergi Paradigm pula. Okay, thank you Diana. Erna Natasha.
Ya, doktor.
Thank you doktor.
Okay, Diana. Erna, you group berapa?
4.
4. Dah present
Dah.
Okay. How the progress?
Sampai pilih yang kompresor.
Okay. Tak ada progress lain lagi?
Belum ada.
Okay. I hope ada lah nanti Okay. Aris sudah. Ifti Fazudin.
Saya doktor.
Ya. Sehat ke?
Sihat.
Sudah puasa ke?
Tak.
Okay lah. How the progress your group?
Grup saya, grup 6. Sekarang ni kita orang dah bagi-bagi tugas untuk buat analisis.
Okay, that's good. I hope nanti akan ada lah nanti progress dia. Nanti saya beritahu bila you kena tentang progress. Thank you. Ilyana Nazwa. Ilyana Nazwa. Ya. You group berapa Ilyana?
Grup 7.
Okay. You ada dekat mana sekarang? UTM ke?
Kat rumah.
Kat rumah.
Pontian.
Pontian. Pontian. Biasa kat Pontian tu. Okay, Liana. Nanti you kena strengthening lah progress dekat group tu juga. Okay?
Okay, doktor.
Okay, Zihan Rosman.
Saya doktor.
Everything okay? You kat mana sekarang?
Saya dekat Pontian dok.
Wah, ini sebelah rumah Eliana aja ni. Satu grup ke? Tak.
Tak, lain grup.
Okay. So, progress dah lebih ke atau masih yang hari tu juga?
Saya sama grup dengan Saiful Fahmi tadi. Baru present.
Okay. Tak ada progress lagi lah dari yang present tadi? Okay. Zulaika. Zulaika. Ya. Zuliaka.
Ya, saya doktor.
Are you okay?
Okay doktor.
Okay you kena aktif dalam grup nanti. Okay. I think your voice ada problem. It's okay, Zulaika. Okay. Muhammad Isamuddin.
Okay, doktor.
How are you?
I'm fine. Saya okay.
Dia dekat mana sekarang?
Kat rumah.
Rumah dekat
Batu Pahat.
Batu Pahat. Okey lah. Batu Pahat tak banyak sangat lah kes
Tak tahu pula. Tak banyak kot.
Kena tengok lah, hati-hati. Yeah. I hope you kena strengthening on the group lah nanti. Okay, thank you. Muhammad Sufian. Makin ngantuk je Sufian. Dah breakfast ke? Tu bangun siang sangat, tak sempat buat apa pun. Saya dah anjak pun, kelas pun juga masih juga. Okay, good. Okay, everything okay Sufian? Okay, good. Alhamdulillah. Kena bersabar lah Okay, doa sama-sama. Muhammad Al-Baqi.
Yes, sir.
Yeah. How are you?
Okay, sir. Alhamdulillah.
Baqi, kat mana sekarang?
Kat rumah.
Siapa? It's not like this class. There is a student apply for datang UTM tapi sekarang tak boleh lah. So, you dah present Baqi?
Dah, sir.
Okay, good. Ya, kena rajin lah siapkan projek cepat bagi baik. Nur Akila Natasha.
Ya, saya doktor.
Yeah. You okay?
Okay.
Okay, Alhamdulillah. So, any problem ke?
Setakat ni tak ada lagi.
Tak ada masalah So, I hope semuanya lancar. Buatlah apa-apa yang ini. It's not only on the component design. Yang lain pun kena buat jugalah. Banyak tu mesti projek-projek. Okay, yeah, then manage masa. Nur Rashidah Musa.
Ada doktor.
How are you?
I'm good.
I'm good. Okay. So how your project, the progress?
Saya sama dengan grup Erna dengan Irene tadi. Saya satu grup dengan dia orang.
Okay. Macam tak ada buat apa-apa lagi tu. Then kena speed up lah
Alright doktor.
Okay. Nur Syamimi. Okay. I hope Mimi okay dia tak ada ini, tak apa. Nur Aisyah Balkis.
Ya, saya.
Everything okay
Okay je, sir.
Sudah present
Dah present.
Today or last 2 days, last 2 weeks?
Last 2 week.
Okay. Any progress?
Tidak sama macam hari lagi.
Okay, tak ada. You kena start lah jangan nanti dekat ujung-ujung nanti susah. Saiful Fahmi tadi dah present. Safinas.
Ya, saya.
Sehat ke?
Sehat.
Okay. How the progress of the project?
Tengah bincang kat dengan grup.
Kena bincang dan buat
Buat je.
Nanti saya tenang nanti kat ujung-ujung nanti susah. Okay,
Okay.
Safinas. Syahrul Razin.
Okay, doktor.
Are you okay?
Okay.
You tidur-tidur ke ni?
Tak ada.
Macam suara sleepy Dekat mana sekarang, Sarah?
Dekat rumah, kat Rawang.
Rawang. Internet okey lah situ kan?
Okay.
Dulu lah, sekarang dah okey dah tu. Okay, thank you Sarul.
Alright.
Syafiq Ismail. Syafiq. Okay, tak ada. Wahidah?
Ya, saya datang.
Wahidah, your group number?
Number 4.
Yeah?
Number 4.
Number 4. Okay. How the progress?
Sama, masih sama.
Masih sama. Then you need to improve lah Saya tenang nanti nanti asal buat je nanti. Yeah.
Yes, sir.
Yeah, you need to manage lah. I know that it's going to be difficult, but I think the platform is there. You need to discuss lah. Where are you right now?
Dekat nilai, sir.
Kat nilai. Nilai 3. Ha?
Ya, dekat dengan situ.
Tak adalah. Saya pernah tinggal around that area dalam 2 years lah. Okay. Alhamdulillah everybody. By next Monday, I want to group present the progress. Yeah, progress. Tried on 10 minutes. Yeah, prepare the progress 10 minutes. Nanti nampaklah apa yang dah buat you present dalam 10 minutes. Yeah, saya fikir cukup today. Yeah. We end the class. I hope next Monday. So this coming Wednesday, there is one topics. After that is finished. Our topic is finished. Then we concentrate on the project. So next Wednesday, I want to all of you present the progress. Yeah, 10 minutes enough. And design semuanya. Okay. Kalau tak ada apa-apa, saya akan end the class today. Assalamualaikum warahmatullahi wabarakatuh. Jaga diri baik-baik. InsyaAllah kita jaga semua. Ya. Assalamualaikum.
Thank you, Doktor.
Ya.